we'll go through. So you're probably kind of aware of this movement from monoliths to microservices. You might have seen this slide in a lot of AWS presentations, but we see a lot of our customers taking this approach of breaking down these large applications that they had developed into the past into smaller microservices. And really the benefits of doing that are that they kind of get these smaller units that they can work with, and it makes it easier to scale each of these parts of their service independently. They can have different independent teams, each working on those microservices, and so they can move quicker. They're less dependent on other teams. They can do things like deploying faster. So there's a lot of benefits to this movement from monoliths to microservices, and we see a lot of our customers taking that approach. In general, we find it makes applications more reliable. It makes them more resilient. If they're decoupled, if one part of the service goes down, it can often not affect another part of the service. And it makes it a lot easier to scale these. So if you have a particular part of your application that's getting a large amount of kind of traffic, you can focus on scaling that particular part rather than having to scale the entire application. So there are, however, some challenges with these distributed systems and with breaking your applications from monoliths into microservices. And one of those challenges is around coupling. So here's an example of a synchronous API that you typically would have in some sort of a microservices architecture. So in this case, we have a customer, the client, who's making a post request to an order service. And then that order service in turn has to make a request to an invoice service to generate an invoice. So what happens here is the order service integrates with the invoice service typically over an API call. And so for the once the invoice service returns a 200 to say, okay, it's received that request and generated the invoice, the order service can then respond back to the customer to say, okay, your request is successful. So a pretty standard type of architecture that you would expect when looking at a set of microservices or application that's broken down into microservices. So at the moment, we would say that those services are decoupled, they're separated out. But what we start to see happens in this microservices architecture is that the order service needs to integrate with a whole lot of other downstream services that are dependent on it. So we started with that invoice service, but we might fairly soon find that we actually need to send an API request to our performance service so that they know when a new order is created. Or we might have a forecasting service that helps us order inventory ahead of time. And so that needs to be updated with information of when an order is placed. And so what ends up happening is this order service actually starts to become quite complex now. It has all of these integrations and dependencies on and couplings on these downstream services. And so if the invoice service changes its API, it then relies on the order service having to go and update the way that it calls that API. Or if, for example, the forecasting service goes down, the order service needs to have logic to be able to retry sending those API requests to the forecasting service when it comes back up. Or if the performance service is running behind and it has really high latency, that's going to have an impact on the order service because it has to wait for that successful request to go through to the performance service. So you start to actually get quite a lot of complexity that you build up into each of your microservices so that they can communicate with each other. And as you span this out, there's more and more services that you'll add, and so the complexity just grows and grows. So another thing that we need to look at is what does failure and recovery look like for this? So as I mentioned, you might have one of those services, downstream services, that end up going down for whatever reason. And so that order service has to think about how does it handle failures? Does it have some way of queuing up failed requests and retrying them? What does the timeout look like? How do certain services want those retries to happen? Do they want it to back off over time? There's a whole lot of different ways that the order service might implement that failure and retry, and it might vary based on each service that it's connecting to. So, the TLDR here is that choreographing APIs is actually pretty hard. And if you look at that kind of happy path of an API workflow, we might have something where, the order service sends this request to the invoicing service and the payment service and the forecasting service. But the payment service actually might then itself have a dependency on the fulfillment service, and then that in turn might have a dependency on the shipping service. So this choreography is actually even more advanced than just the order service, but each of those other services themselves might have downstream dependencies. So for example, what happens if we're out of stock? The fulfillment service actually has to have a way to communicate back to the invoicing service to say, hold up, there's a problem here. It might also have to go back to the payment service to cancel that payment. And the shipping service, itself might have to update an invoice once a shipment has actually been delivered. We also need to look at situations, as we've talked about, where that forecasting service might go down. So there's all of these kind of interdependencies. And as we mentioned in that earlier architecture, you often also have to add certain dependencies at a later stage. So here we might introduce a reward service that's an entirely new service, and that needs to receive order events. But it also might need to receive events from the fulfillment or shipping service to know, for example, if an order is being canceled. So the kind of result here is that there's a lot of this like different arrows going to different places, services that need to know about what's happening with another service. And so really you get this kind of map of API connections between all of your different microservices. And all of that needs to handle retry logic, to handle failures, to know about how the API for each of these services works. We talked a bit about availability. Sorry, this is Ben's slide, so I'm trying to figure out what's going on in this bit. But talking about how the payment service itself might go down. And at the moment, when you have a tight coupling between your APIs and the synchronous APIs between microservices, the payment service going down here would take down the order service. And so when we're trying to make our applications more resilient, that coupling that you get through synchronous APIs can mean that some sort of impact on one of your services can take down other services. So the question really is, how can events help with these challenges that we've seen of failures, of coupling between our microservices? So before we get into that, let's first take a look at what an event actually is. And so the definition here is that it's a signal that a system state has changed. So if we look at events, we find that they are actually synchronous and asynchronous and not synchronous compared to API calls. So we've seen our commands in an API are typically, you have to send a command and then wait for a response. And so if you have multiple services, your client sends that request to your first service. It in turn needs to send a request to another service. And so your service A can only respond to a client once it gets that response from service B. It's synchronous, in other words. Whereas with events, it's asynchronous. So a client sends a request to service A, and it's immediately able to send a response to the client without having to wait for a response from service B. And so actually, service A does not care at all about service B and what it does with that event. It's totally asynchronous. The other thing with events is that they are observable and not directed. So if we look at direct commands that we would get in a synchronous API call, here's an example of someone saying, please create an invoice. And then the invoice service responds with, okay, here's the invoice. So that's the synchronous directed commands that you see with API connections. Whereas with events, they're more observable. So you would have in this example, customer X just ordered a widget, and that gets broadcasted out. And then anyone that's listening can observe that event and decide whether it needs to do something with it. So some other microservice might say, okay, well, I'll send an invoice. Whereas someone else might, which is a specific action, whereas someone says, okay, I'll just add that to a sales report. And so there's not necessarily an impact that's happening to the customer after that. So that difference there is these events are observable, they're not directed, and the generator of the event has no idea who is going to use that event downstream, or which service is going to use that downstream. So going back to that original architecture that we saw with the order service, the way that we would change this implementation to go from this coupled synchronous integration between our microservices to an event-driven approach is to have that order service instead generate an event to say, hey, an order was created. And the idea then is that all of these downstream services can observe that event and, if necessary, take action on it. So we have this idea that with the event bus, and we're getting a bit more towards the EventBridge side of things here, where you have all of these observable events being sent to a central bus, and then your consumers can selectively filter the events that they are interested in. So going back to our original examples, you might find that the reward service is interested in observing these new order events. But there might be another service, for example, the shipping service, that doesn't care about new order events until such time as it receives some detail from the payment service or from the fulfillment service. And so, so there's this need to be able to filter the types of events that you receive. So that's really where EventBridge and the concept of an event bus and being able to filter events comes in. And so really the idea here is that the event bus does all of this coordination for us. So the order service is able to send an event to the event bus with a, hey, a new order is created. And then all of these downstream services can create rules or filters that allow them to select the events that they want to listen to. So one of these services might say, hey, I'm interested in your order events. And so the event bus will then route those events to that service. But other services might say, well, I don't care about the new order created events. And so they don't receive those events. And so it's the event bus and the rules and routing that are created on the event bus that help to route those events. So there's just a couple of nice animations that I was not expecting. And just kind of showing what that looks like with the architecture that we've talked about earlier. We have these downstream services that are connected to the event bus and using rules to determine which events they receive. And so when we add more services, instead of the order service having to integrate with each of these services directly, for example, we've added the reward service. The reward service simply says to the event bus, I'm interested in these new order events, and it will start to receive them. The event bus will route those events to the reward service. And so the order service doesn't even have to know that the reward service is looking at those events, observing them, and using them. It's just simply emitting its new order events to the event bus. So really, events with Amazon EventBridge, you have this concept where all of those microservices are pointing at the event bus instead of at the order service itself. And your services don't need to know about each other. They don't need to know who is consuming their events that they're generating. They simply generate those events and allow anyone to subscribe to them. Okay, so how do you expand beyond your own systems? One of the other parts of EventBridge that we kind of support is the ability to get events from third-party systems. And so the examples I've used up until now are all about receiving events from your own applications, your own microservices. But very often you have integrations with other services that you need to get data from. We see a lot of SaaS applications being used in businesses today. Things like SAP, like Salesforce, accounting software. There's a whole lot of SaaS applications that businesses are using. And one of the problems with these SaaS applications is that it can be difficult to pull out data from them and share it with other applications that you're using. So you might, for example, have data in Salesforce about new leads, and you want to be able to sync that up with your invoice data to be able to see which of your leads are actually converting to generating sales. And so moving that data between your systems can be tricky, or getting that data out of something like Salesforce can be tricky. So let's take a look at how customers are doing that today. So one approach is polling an API. So you might have a SaaS app that has an API available to you, and you can query their API for new data. So you might, maybe an example is something like Zendesk, which is a support ticketing platform. You might have support tickets that are created, and whenever those tickets are created, you want to associate that with other data in a database that you have. And so one way that you could get that is by querying the Zendesk API using, for example, a Lambda function to determine which new support tickets have been created. And every time a new support ticket is created, you would go and update your database with that information. And so that's one approach. And one of the issues with this is that you have to maintain all of this data, this infrastructure for being able to poll that API. So you have to have some sort of cron service. You have to have code that actually integrates with the API. You have to make sure that that's running on a consistent basis. And it's kind of inefficient as well. There's going to be a whole lot of times where that function is running and polling the API, but there actually aren't any changes in the data. And so it's kind of inefficient because there's no changes, but you're still having to run that code. So another approach that's slightly more efficient is to use webhooks. And so a lot of SaaS applications now allow you to specify an HTTP endpoint and generate a request to that endpoint. And this is a lot more efficient than API polling, but it's still kind of a hassle. You have to set up an HTTP endpoint. You have to think about authentication on that endpoint. You don't want to just expose it publicly to anyone on the internet. So you might do something like looking at adding a secret to the HTTP request so that that hashes the payload, so that you and the SaaS application can agree on whether this is a verified request. You might have to add some sort of custom authorizer to your endpoint. There's various ways you can do that, but it means that you have to maintain this HTTP endpoint to receive all that data. You have to think about authentication. And so there's a fair amount of work that you have to do on that end. And then when you're sending that data to your downstream services, your HTTP endpoint has to think about retry logic. So if one of your applications that's going to deal with that HTTP webhook goes down, you want some sort of a way of being able to retry all of those events that you've received or webhooks that you've received. So again, quite a lot of complexity that you have to build to do webhooks well. I think we've covered that. So with EventBridge, we looked at this and said, well, is there a way that we can do webhooks better for customers? And that's why we've launched the third-party integrations with SaaS applications. And so with EventBridge, not only can you get events from your own microservices, but also from these third-party applications. And that allows you to centralize all of them in a single event bus where anyone that is interested in those events can observe them, create a rule, and route them to the service that they're interested in using. So this is where we'll get into EventBridge itself and talking a bit more about that. But before I do that, I want to talk a little bit more about serverless. At the beginning of the call, we talked a bit about it, so I think a lot of people are familiar with this. But some of the kind of benefits of serverless is that there's no infrastructure that you have to provision or manage. So there's no services that you have to deploy. You don't have to worry about scaling those services. Amazon handles all of that for you. So we take care of all of the patching, of all of the security of those services, and you as a customer only pay for what you use. So there's no situation where you have some sort of resource that is just sitting there idly. If you don't have requests or usage of that resource, you won't pay for it. And so really you have this ability to scale based on whatever usage you have. If you have 1 or 2 requests a day, you'll only pay a small amount for that. And if that suddenly grows to 1 million requests in a day, you don't have to do anything to provision additional capacity or to scale up your infrastructure. So if you kind of look at how event-driven architectures and serverless fit together, what we really see in our kind of serverless setup is at the heart of it, these serverless functions as a service. So that's things like Lambda, which you're probably quite familiar with. And really event-driven computing sits on top of this infrastructure. So it combines things like Lambda, EventBridge, in some cases API Gateway, to allow you to build these event-driven applications on top of serverless infrastructure or services. So, kind of plotting out what that looks like, you might have a source of your events. That could be anything from a partner SaaS application, your own application that you've built, microservices, and some sort of change in data happens in that source application. That then gets routed to a serverless function, so running on something like Lambda. And you can write Lambda functions in a wide range of different languages. And then that Lambda function can do various things with that particular event. So if a new support ticket is created, it might, for example, automatically update that support ticket to assign a support agent for it. Or it might go and update a particular database that you have to say that a customer has created a support ticket. And so really that's when you're thinking about event-driven architectures and how that connects to serverless. This is sort of a typical kind of architecture and the different services you might use. I'm going to skip this slide because I have no idea what Ben was going to say on it. And then we'll get into the EventBridge side of things. So we saw earlier that EventBridge provides you with a way to route events between your SaaS applications, between your own applications that you build, and route those to different targets. EventBridge itself is fully managed, so you don't have to scale EventBridge as you get more usage of it. If you've used other services like Kinesis or Kafka, or MQ, for example, you might be familiar with having to add streams or adding brokers as you scale up your usage. With EventBridge, you don't have to do any of that. We take care of all of the scaling for you, and you only pay for what you use. So EventBridge charges for $1 per million events published to an event bus. And so if you don't generate any events, you don't pay for it. It's integrated with over 90 AWS services as sources. So, for example, if you start up an EC2 instance, you'll receive an event on EventBridge to say this EC2 instance has changed state from starting to starting up. If you put an object in S3, you can get an event for that in AWS. So in addition to supporting third-party SaaS applications and events from your own services, we also support AWS services. And then there's no additional cost for delivering these events to different targets. So that's a bit of background on EventBridge itself. But let's actually take a dive into the architecture of EventBridge or the different components that make up EventBridge. So starting on the left-hand side, we have these event sources. And I've talked about how those range from these AWS services that you're using that generate events. Those all come into a default event bus in EventBridge. You can send custom events from your own applications and then receive events from applications like Zendesk or Datadog. There's a whole range that we support. The next side of it is the event bus. And the event bus is really the core part of EventBridge. And it's the logical kind of unit through which all events pass. So for AWS services, all AWS accounts have a default event bus to which AWS services send their events. But you can also create custom event buses and send events from your own applications or SaaS applications to those custom event buses. So you might say, well, I have an order service, and this order service has a whole bunch of other microservices around it. Potentially it fits into this e-commerce solution. And so you want to have all of those microservices communicating. And the idea is that you would create a single event bus. You might call it your e-commerce event bus, and then have all of your events from all of those microservices funnel into that single event bus. And so this is a bit different from other kind of messaging services where you might be used to creating a separate topic for different types of events that you're sending. The idea with EventBridge is that you can send all of those events to the central event bus, and that makes it really easy for publishers and subscribers to figure out where the events are. And the big difference with EventBridge is that once you have all of those events on the central event bus, it's very easy and to be able to select the events that you want to route to a different place. And the way that we do that is through rules. And rules are a really powerful way to express this routing language of which events you want to send to a particular target. So on the left-hand side, I've got an example event here. In this case, it's an event where a ticket is created. It's coming from a particular partner that we've got listed here. And it's got a payload in this detail section with some more details related to that ticket created event. So it's got a ticket ID, a department in which the ticket was created, and the user that created the ticket. And it's probably got a whole lot of other detail, but I've just limited it to that for this example. So the way that we would use a rule on EventBridge is we would create a rule on top of this e-commerce event bus, or whatever event bus that this event is coming to, and then use a JSON pattern to express the types of events that we want to match against. So one example of a rule here might be us saying, well, we actually just want to match against any event that comes from this particular partner. And so because we've said here the source of this for this rule is this AWS partner example 123, because this event over here comes from that particular source, it will match this rule and trigger this particular rule. We can get more advanced with rules. We could say, well, actually, we're interested in any tickets that are either from the billing department or from the fulfillment department. And so because this particular event is from the billing department, it will match against this rule and trigger this particular rule. But then we might have an example where we have a rule that's looking at the ticket resolved events. And because this is a ticket created event, it won't match against this rule. And so this rule is not triggered by this particular event. So rules can get really advanced. We can do things like prefix matching. We could say we want to match against any value in a field that starts with something. We can do numeric comparisons. So we could say we're looking for a field where the value is between 10 and 100. So you might, for example, only care about orders that are created over $1,000. You might want to do some additional fraud analysis on that. So your rule pattern could say simply creating a rule where the price is greater than $1,000, and that rule would only be triggered when you get an event or an order placed over $1,000. So rules are a really powerful way to express the types of events that you want to route to a particular target. And so each rule has a single at least one target and up to 5 targets for each rule. And these can be any of, I think, about 18 AWS services that we support. So you can route events to things like Lambda, step functions, Kinesis, SNS, SQS. There's a whole bunch of different AWS targets that we support sending these events to. And so you might have a step function that takes a whole bunch of actions based on a particular event. And using the rule, you can get very specific about the types of events that you want to send to that step function. So that's a bit of an overview of EventBridge itself and kind of the structure of it and how the different components work. What I thought I'd do now is just hop into a quick demo of showing you how we can get events from a third party like Zendesk, do something interesting with them in AWS. So I'm going to hop over to my browser and give you a quick run through of how all of that looks and how that works. So I'm in the AWS console here. I've got into Amazon EventBridge, and you can see some details over here. On the left-hand side, we've got some of those concepts that we discussed, event buses, rules, and then these partner event sources. And I'll just say now, you'll have to excuse all of the stuff in my account. This is my test account, so there's a whole lot going on here, but hopefully you can still follow along. So what I'm wanting to do with this example is I have Zendesk set up. I'm using it to capture support tickets in Zendesk. And I'm wanting to do sentiment analysis on my Zendesk support tickets to say, when a new support ticket is created in Zendesk, I want to actually go and determine, is the sentiment in that ticket negative? And if it is, I want to increase the priority of that ticket and mark it for a manager to look at. And this will allow my support agents to kind of better pick up tickets that are high priority. So the way that I'll do that is I'll go and connect up Zendesk so that it's sending events to EventBridge whenever a new ticket is created. I'll then create a rule that routes those events to a Lambda function that I've created that does sentiment analysis and using Amazon Comprehend, and then updates that Zendesk ticket when it detects there's a negative sentiment. So let's go and see how we'll hook that up. I go into the partner event sources section here. You can see I've got a couple of event sources created, but over here we have a list of partners that are supported by EventBridge. So you might recognize some of these, and we're adding to this list all of the time. If you work for a company that you think might be an interesting partner, please get in touch with me as well. We're always looking for more opportunity to list more partners on this page. So I can see up at the top here, Zendesk has this integration. And if I go into this, I can read some more detail about the integration itself. We talk about some use cases and a bit of detail about how this all works. But what I'll do next is then go to the setup event source section. And there's a few short steps to get to start receiving events from Zendesk. So the first thing I do is I copy my AWS account ID. And I do this because I need to give this to Zendesk so that they can initiate the connection from their end. From there, I go and visit Zendesk, my Zendesk portal. I've opened that up here. And we have this integrations page on Zendesk. And so you can see this has got this section here to connect Zendesk to Amazon EventBridge. So I'll hit the connect button here and then paste in the AWS account ID that I copied from the previous page. I then need to choose the region that I want to start receiving events in. So I'm using US East 1 at the moment, so I'll select that from the dropdown, and then choose the type of Zendesk events that I want to receive. So I can just select support tickets, but I'll go ahead and just say I want to receive any events from Zendesk. So what I then do is I hit the connect button. And what happens in the background now is Zendesk go ahead and create what's called a partner event source. So this is created in Zendesk's own AWS account, but it's shared with me as the customer based on that AWS account ID that I provided them with. So if I now go back to EventBridge and I click on this partner event sources, what you'll see is I have this new Zendesk event source, and it's in the pending state. So I don't actually have any event buses associated with this event source. And so I won't receive any events related to Zendesk until I associate that with an event bus. So I'll select that event source and say associate with event bus. I can set some permissions here if I want to, but I'm happy with the defaults, and I'll say associate. And so what I now have is this source of events from Zendesk, which is connected to an event bus that I've created. And so any events that Zendesk sends will now appear on this event bus. And if I go into my event buses, I can see it listed down here at the bottom. The thing is that because I don't yet have any rules created on this event bus, any events that Zendesk sends actually won't do anything. EventBridge will just drop them. And so to do something useful with those events, I need to create a rule that tells EventBridge where to route those events. So I'm going to go ahead and hit the create rule button and then fill in the details here. So this is my sentiment analysis rule. I'm going to leave out the description, and then I can fill in my event pattern. Now, what I'm going to do here, just to keep this basic, is say I want to match against any event that's created. So when I do that, it just gives me this very broad rule pattern that says match against any event that is from this particular account, and that's my AWS account. But I could go in and I could expand this, and I could say, well, I'm actually looking for events where the department is billing. And so that would kind of scope this rule down and ensure that I only get events where the ticket has a department reference that is billing. But for now, I'm just going to keep this really broad and just say that I'll match against any event that gets sent on this event bus. What I'll then do is just choose the bus that I want to create this rule on. So it's got that Zendesk event bus selected. And then I choose the target that I want to route events to. So you can see there's a whole bunch of different AWS targets that we support, things like an ECS task. You could send this to Kinesis Firehose, to Kinesis Stream, to SNS, SQS, and Lambda step functions. So in this case, I'll choose Lambda. And then I have a mess of Lambda functions, but I'm specifically looking for this Zendesk Ruby function. And I'll hop over just now to kind of show you what that looks like as well. So I create my rule, and you can see now that rule is active and enabled on this event bus. So hopping over to that Lambda function quickly, I'll show you what that does. So if I go into, what did I call it? Zendesk Ruby, I think it was. There we go. So this is a really basic Ruby function that I've written. And if I show you the code on this just quickly, what this very simply does is it receives an event when the Lambda function is invoked. So EventBridge sends this event to the Lambda function. I then map out a couple of variables here. So I define the comment and the ticket ID. I scope those to particular variables in the JSON of that event. Then I make a call to Amazon comprehend to do that sentiment analysis on the comment of the ticket. And I then say, if the sentiment for that particular comment is negative, I want to run this update Zendesk function to set the priority to urgent and to add these particular manager required and priority support tags to my Zendesk ticket. And then I just have a basic Zendesk ticket function, update function that'll go and make an API request to Zendesk's API to update that particular ticket. So a fairly basic Lambda function. So now that I have that all hooked up, what I can do is go into my Zendesk agent. And so I'm going to simulate creating a ticket here, but you might have some sort of form on your website that allows customers to create these tickets. So you can see I have no tickets that are currently set up here. I'm going to go ahead and add one. This is my test ticket. And I'm going to say something really negative to make sure that Amazon Comprehend picks this up as negative sentiment. So this is really bad. I am very sad with your service. So making sure that we pick up that negative sentiment. So what I'll do is I'll now submit this ticket, and you'll see that it shows up in my list of tickets. It's just being created. But if you look here, the priority is not set. And so the ticket is just being created. But if I go and refresh this particular view, you can see the priority has been updated to urgent. And if I go into that ticket, you can see these tags, manager required and priority support has been added. And so what happened in the background, it kind of goes quite quickly, but what happened is I created the ticket on Zendesk. That generated an event to the EventBridge event bus that I have created to say a new ticket is being created. That matched against the rule on my event bus that routed that event to a Lambda function. The Lambda function then called Amazon Comprehend to do sentiment analysis on that ticket. It detected that it was negative sentiment, and so it made that API call to then update the ticket. So you can see we've built this application that doesn't require us to do any polling of Zendesk. It doesn't need us to set up webhooks, and we're able to act on those events generated by Zendesk. So yeah, that's a quick example of the kind of way that the partner integrations work on EventBridge. I'm going to hop back to the presentation here, and I think there were some slides that I somehow skipped past. So let me just see if I can find those. So I want to go back just to talking a bit more about the kind of way that you would build your microservices to use EventBridge and to integrate with it. So going back to that example of the order service and the invoice service related to it, let's take a little bit of a look from like a code perspective of what that actually looks like to use EventBridge with this service and how we can put that put the event bus between the two services. So on the left-hand side, I've got an example Lambda function that very basically puts together a JSON event, and you can see that it's got this detail field over here, and it just is some JSON with the order ID, the state. We would probably have a bunch more data in this particular event. We've also then got the detail type. We're saying this is the new order event, and it comes from our service demo orders. So a couple of fields that we require when you're creating an event on EventBridge, the detail type and the source. This allows you to identify the event, the type of event that you're sending through. And then the detail gets the payload of this particular event. So in our code, just showing you a kind of snippet of this, what we do is just generate that JSON of the event and then simply call the put events API with that particular JSON payload. So this would actually use the AWS SDK, and it calls the put events API in EventBridge to send that event to EventBridge. We then receive that event on our event bus, and we would set up a rule that then routes that event to a Lambda function that will handle that particular event. So you saw with that Zendesk function that I had, the Lambda function receives this event, and it can then have some custom code that reacts to that particular event. So to kind of hook that up, and in between all of that, we create this rule that will route the event. And here you can see some CloudFormation snippet just to kind of show how easy that is to create a rule in CloudFormation. We've created this rule. We give it a description. We can, in YAML, just define the source and the detail type, as well as the state. So this creates that particular pattern that we've been seeing that you can use in the rules, and then sets a target as our Lambda function. So a fairly easy thing to just include in a CloudFormation template if you're using that. So, what if we then come along and we say, well, we want to add the reward service to that particular example? All we need to do is add this new target to our rule and add the reward service Lambda function as a target. So if it wants to receive that same set of events, you don't even need to create a new rule. You can just add an additional target for the reward service. And then EventBridge will take care of sending the event both to your invoice service as well as to your reward service. So really easy to kind of expand that. But potentially you might have some sort of logic that says, well, actually your reward service is only interested in orders above $10. You could then go and create another rule that maybe has another field here like price, and it says greater than 10. And then has your reward service as the target of that particular rule. So just a kind of quick example of how you would use EventBridge with your own events. The last little bit that I want to cover is a service that we launched, or a feature that we launched in December last year at reInvent, called the Amazon EventBridge Schema Registry. So what we heard from customers that were building event-driven applications is that it can be kind of difficult to actually know what events look like, what the structure of an event is, or what we call the schema of an event. And so as you start to add all of your microservices to an event-driven architecture, and they're all sending their events to this event bus, how do you know what events are available? And how do you know what data is available within each of those events? And so this is where the schema registry comes in, is that it makes it really easy for developers to search the central source of truth of the schema of all of the events created in or being sent to your event bus. We've made it really easy to generate the schemas of your events by using this feature called Schema Discovery. And so what that allows you to do is enable discovery on a event bus that you're sending events to. And when you do that, EventBridge will actually scan all of the events being sent to that event bus and automatically generate schemas for those events in the schema registry. Once you have events in the schema registry, it's then really easy for you to generate code bindings, which provide you with class files in your code that represent that particular event. So you get the strongly typed object in your code that is based on the structure or the schema of the event that you're generating. So I'll quickly hop over just to the console to show you a bit about how that works. So I go into Amazon EventBridge. I then go to the schema registry, into the schemas section. And you can see that we have schemas for AWS services. So all of your events that you're getting from AWS services, if you're familiar with CloudWatch events, it's those same events. For example, the EC2 events that we can get. We talked about that instant state change event, which I for some reason can't see now. Let's see. So there's these events for AWS services, but then you can also get the schemas for your own applications. And so I can go into this discovered schema registry, and these are all schemas for events that I've sent through to my event buses. So, for example, I have this order system with an order created event. So if I go into that, you can see that I'm able to see the schema of that particular event. So I can see that it includes things like a shipping ID, a price, the currency, the category. I can see that the category is a string, that the order ID is a number, that the price is actually got some additional details to it. So that's an object with a shipping price, the total price, and item price, and taxes. So I can very easily see what that particular event looks like. I can also then download a code binding for it. So I can say, well, I'm using Python, so I'll download this code library. And if I extract that and take a look at it, you can see that it's generated this set of class files for me. And if I just switch to Sublime quickly and pull one of these in, you can see that I have this class file in Python that represents this particular schema of the event that I've got. So it figures out the typing for each of those fields within the event itself. This is kind of a very handy way if you're wanting to quickly start writing code that reacts to a particular event. You can go into the schema registry, download the code binding, pull that into your code project, and then immediately you have the structure of the event, and you can use all of the features like autocomplete related to that event. So, okay, let me get to the kind of like final bits here. I think what we've really wanted to try and convey with the presentation today is that EventBridge and event-driven architectures allow you to decouple your applications in a way that you don't have to have all of these API calls between your different microservices, and that using rules, you can really simplify the way that you route events and have this model of a central event bus to which all of your events are sent, the ability to use a schema registry on that to keep track of all of those events, and then using rules route specific events to a particular target. All of this should hopefully allow you to then build applications that have much better availability because they're totally decoupled, they're not reliant on each other. And that if you have third-party integrations that you need to do, you can get rid of all of that kind of plumbing infrastructure that you need to do API polling or receiving webhooks. So that's kind of the background to event-driven architectures and EventBridge. I'll kind of pause here just to see if there are questions, and I'll stop my screen share and just go into the chat just to kind of get some more detail there.